I already have the environment ready. These are the source tables. We have account, customer, ledger, loan, and transaction. So let's look at the tables one by one. This is the transaction table. As I have already shown you that the transaction table does not have any source country or destination country, but it has source account ID and destination account ID. So we'll have to join this with the account table, it seems, because account table has the account ID. So you can get the source account ID and destination account ID and the source customer ID and the destination customer ID. So after that, we'll have to join with the customer table, which contains the customer ID and the country. So I'll get the source country and the destination country. Now, one more thing is that the Redshift target table is already available here because we had run the glue crawler on Redshift, but will not be using the data catalog, we'll be using the from options. And this is the Redshift or the target environment, which is OLAP Redshift. In this environment, we have this cross-country transaction detail table, and let's do a count star. It should be empty now. So there are no records in this particular table. All right. So let us go ahead and create a script from scratch, which will be used to load records from MySQL to Redshift using PySpark on Glue rather than the Glue API. The previous one was Glue API OLTP MySQL to OLAP Redshift. I'll create a script with the name PySpark OLTP MySQL to OLAP Redshift. So the engine should be Spark, and let's rename it. And we have all the available options here, but we'll have to import the dynamic frame so that it can be used to write to the final Redshift target. Everything else would remain the same, nothing is getting changed. I have the Spark session and all these things are there, but I'll have to configure the job details. In the job details, I need an IAM role as usual. Let's not use the automatically scale the number of workers. I'll request 10 number of workers. So in this case, Glue would automatically create 10 workers. So all the time 10 workers would be used. Job bookmark is disabled because I do not want to keep a track of what data has been processed. There's no number of retries, but in advanced properties, I will have to add the connection information. Let's mention the concurrency to be 2 or maybe 3, and then the connection option. So this is the Redshift connection that we had created earlier. So I'll be using this connection and I'll be adding this connection in the job details. This is very important step. If you do not do this, then the final writing of data to Redshift will fail. So let us save this, and now let us do the coding of the script using PySpark. These are the two URLs. This is for the source MySQL JDBC URL. This is the target Redshift JDBC URL. You can get the Redshift JDBC URL from here. You can go to the Redshift cluster, and there are multiple options here. We have endpoint, you have JDBC URL and ODBC URL. So you can copy this JDBC URL and then use the same URL here. Right, now we'll have to create 3 data frames. One should be for transaction, another would be for account, and the third would be for customer. And these data frames have to be created by reading records from the MySQL tables which are there in Aurora cluster. So we'll have to use a JDBC data frame reader. So I have created all the 3 data frames. This is the first one. Format is JDBC. I'm using MySQL JDBC URL. The user is the user that I had provided, followed by the password, the driver, and the table name is transaction. Now after this, I have created one more data frame wherein I'm selecting only transaction ID, account ID, source account ID, destination account ID, and the transaction amount. Similarly, I have created df underscore account data frame, and I'm reading it from the account table, and df underscore cx data frame, which is being read from the customer table in MySQL. Now let's define the logic. First, we'll have to join the transaction table with the account table. And this is the data frame that I'm creating, df underscore transaction source account join. So I'm joining for the source account ID, and I'm getting the customer ID for the source account ID only. This is the join, this is a left join, and then you have the select transformation wherein I'm selecting only the required fields. I need the transaction ID, source account ID, transaction amount, and customer ID. Now you see I'm using the dot notation here, which is data frame dot transaction ID. And after that, I'm using the column function to rename the customer ID as source customer ID. Of course, I'll have to import the column function, and it would be needed in multiple places. So this is the first data frame. The second data frame would be for destination account join, which is this one. Here again, I'm joining the account table with the transaction table, but the join column is different. In the previous one, I had used the source account ID of the transaction table and the account ID of the account table to join these two data frames. Now this time around, I'm using the destination account ID from transaction table and account ID from account table. And the number of columns that I'm selecting are also less. I do not need all of them. I need the transaction ID, destination account ID, and the customer ID. But the customer ID is being renamed as destination customer ID. Why am I doing it? Because I have customer ID here also, and I have customer ID here as well. Not only that, it will give me better readability so that we can get the source customer name or source country and the destination country. Now I'll have to join these two tables. In the previous case, I had used a left join, as you can see here, because I want to get all the transactions even though there are no records in the account table, because I'm not using all the files here. I'm using only one file. In your project, you'll get all the files. You'll be doing project using the same data set. So that's why I'm using left join for this one and this one. Now I'll have to join these two data frames. Why? Because I want to get the transaction ID, the source account ID, source customer ID, destination account ID, and destination customer ID. That is the purpose to join these two data frames, because I have got the source customer ID here and the destination customer ID here. And this time I'm using the inner join, and I'm joining on transaction ID from the source account join and the destination account join. So this is done. I have got the customer information from the account table, but we have to get the customer country, meaning we need to get the source customer country and the destination customer country. Because you see in Redshift that the table contains source country, destination country, total amount, and total count. That's what it contains. So that's why to get the source country and the destination country, we'll be using the customer table, wherein we have the customer country along with the customer ID. Okay, this is a little heavy duty, because first, what am I doing is I'm joining the transaction account with the customer data frame. And first time the join is based on source customer ID. Now the source customer ID is in the data frame df transaction account, an inner join in this case. And after that, I'm selecting the transaction ID, the source account ID, the amount, the source customer ID, destination account ID, destination customer ID, and the country column, which is there in the customer table. But I'm renaming it as source country. So I'm using the column function, which I have already imported, and I'm using the alias function of that to rename the country as source country or src underscore country. The reason I have used this name, because in the Redshift target table, the column name is src underscore country. After that, I'm joining the output, which is this one, with customer data frame again. But this time, I'm using the destination customer ID to join. Or let me use a different data frame for this one. I'll name it as prefinal 2, and I'll join prefinal 1 data frame with the customer ID. But instead of the df transaction account, I'll be using the df prefinal 1 data frame. And of course, I'll be using the customer data frame and the customer ID, and the join would be inner join. I'm selecting transaction ID, source account ID, amount, source customer ID, destination account ID, destination customer ID, and source country. Now the country that I'm getting from this join, I'm renaming it as destination country. So we are almost done now. The final piece is to do the aggregation. We have done all the joining, we have done all the transformations. So finally, we'll have to do the transformation as per the target table. Now see, the target table contains total amount and total count, meaning total amount that has happened for each source and destination country combination, and also what is the total number of count. So count is nothing but the transaction count. So let's use group by, and the column should be source country and destination country, and I'm using the aggregate function, and inside of aggregate function I'm using the sum aggregation to aggregate the amount which has been grouped by this, and I'm renaming it as total amount, and then the count function, and I'm renaming it as total count. But before that I'll have to import the sum and count functions. Okay, so this is done. Now this is the final data frame. So the final data frame is ready. Now we have to write this data frame to Redshift. But as I told you that I'll have to convert the data frame to a dynamic frame, because we'll be using dynamic frame to write to the Redshift. And this is the only place where we'll be using the Glue API. And this is the code to create dynamic frame. This is the name of the dynamic frame, Redshift dynamic frame. And I'm using the dynamic frame that I had imported earlier. And then the from df API, this is the name of the data frame, and I have to pass the glue context and the name of the dynamic frame. You can name it anything, but it's better to name it similar to the name of the dynamic frame. Now I'll be using the write dynamic frame glue API to write it to Redshift. From here to here, we are using the glue API, and the API is write dynamic frame from options. The reason, as I told you, I'm not using catalog because it might not be the case that the Redshift tables are available in catalog. As a best practice, if you're using AWS environment and if you're using Glue to write to Redshift, whenever you create a table in Redshift, it's better to run a crawler. So you can automate that process. But anyway, I'm using the from options. If the table is available in catalog, then you can mention from catalog. The frame is actually the input dynamic frame that we have created. So this is the dynamic frame that I had created from the data frame. The connection type is Redshift, then you have connection options. The URL is the Redshift JDBC URL, which I had already provided earlier. This is the Redshift user and its corresponding password. This is the user who can connect to the Redshift cluster and the database and write to this table. So the user should have proper authentication and authorization. I've used an admin user, so that's fine. Then we have the Redshift temp directory. This is the directory where Glue will write the temporary file, and from there it would be copied to Redshift. Let me show you the directory. This is the one which is 3im Spark output temp. You do not have to create the temp folder, it would be automatically created by Glue. But once the record is written here, or once the file is written here, it would be copied to Redshift. That is how it works. By default, the output format is CSV, but you can change it to Parquet. Then you have the AWS IAM role. Now this is the role for Redshift. So this is a Redshift service role which has access to read from S3 or write to S3. Data or file to S3 would be written by Glue. So in the job details, I have already provided the role which has admin access, so it can write to S3. But this is the role which can or which should be able to read from S3 folder. And let me show you the role. So this is the role, data engineering on AWS Redshift S3 full access role. It has Redshift all commands full access, Redshift query editor, and Amazon Redshift full access. This is a role, and you see the trust relationship. It is redshift.amazonaws.com in the service or in the principal, right? So this is the ARN that I have copied here. Then the use connection properties should be true, and then the name of the table. The table was created in public schema, and this is the name, right? Cross country transaction details. And then we'll have to provide the name of the connection. And I have already added the connection in the advanced properties earlier manually. If you do not add this and then run the script, it would fail. Then you provide transformation context. It is optional, but before that, let me use the format as Parquet to write to this temporary location. So let me save this and run this job. It will take some time for this job to get completed. So let me start the execution. Hopefully everything is fine. If not, it will error out. Of course, we'll debug the error. The job completed finally after multiple failures actually. So let me tell you what these failures are. Anyway, I'll be having another video after this to show you some of the failures that you can expect. The first was the syntax error. I had mentioned an dot. The second one is also a syntax error. So there was some unresolved column. I had to change the code a little bit, which is pretty straightforward. From the third one, as you can see, the error was O285 PyWrite dynamic frame. So it says mkdir failed to create file, etc., etc. And I had tried multiple options. I ran it multiple times, but it was failing. Eventually, it was successful. And the change that I had made was I had removed the format Parquet from the write dynamic frame API. So by default, it writes in CSV, but I had mentioned Parquet format. That's why it was giving some error. There are some other ways to solve it, but if you get similar errors, it's better to raise an AWS support ticket to get help. Okay, so before talking about more errors, let's look at the output. The reason I wanted to look at the output first, because the output will not be correct. I'll tell you why. First, let's look at the number of count. And only 12 rows have been added. Now let's do a select star. This is the source country and this is the destination country, and we have only 12 combination of the same, which is correct. But look at the other columns like the total AMT, total count, total amount, total count long, and total amount decimal or total AMT decimal 28.2. Now, why this happened? Let's look at our table first. Here's our table. We have the source country as text, destination country as text, but the total amount is decimal 22, or the total AMT is decimal 22, and the total count is INT. If you look at the output, first of all, the total AMT is null, then again, total count is also null, but here we have total count long, and here we have total AMT decimal 28.2. The reason is because we don't not only have to match the column names, you also have to match the data type. So I'll have to change the script so that the total AMT and total count is decimal 22 and INT data types. So let's go to the script editor, and this is my final data frame. The aggregate sum is amount. Let's do a cast after this, and then we'll do the alias as total amount. Similarly, we'll do a cast of count also. Okay, in the first one, I'll have to cast it as decimal type, and the decimal type should be 20,2, and the count should be integer type, because the data type in Redshift is decimal 22 for total AMT and total count is INT. This is a little tricky because you have to make sure that the data type, the name of the columns, everything match. And I'll have to import all these. So I've imported the decimal type and the integer type. So now let's save it again and run the code one more time. Let's see how the output is. The column names are same. I hope the total count is the name here also. So it is total underscore count and total AMT. Total AMT is decimal 2 and total count is integer. And that's what we have done. We have casted the output to decimal type 22 and the count star to integer type. Okay, one more thing that I noticed is that in the final data frame, I was not using the pre-final 3, I was using the pre-final 2. I have changed it and remaining things are the same. And then I have deleted the records. Now there are no rows in the Redshift table, the count is 0. Now let us go ahead and execute this. First I'll save and then execute. All right, the job succeeded. Let's look at the count. So we have 12 rows and these are the same rows that we had looked earlier also. But this time the output should be correct, except that we have the total amount. So we have source country or SRC country, destination country, total amount, and I can see the total amount here correctly and the total count, which is 16. We also have total amount. Might be the case that in the script somewhere I'm using total amount. Anyway, that's okay. We can fix it later on. But this is how we can use PySpark on AWS Glue to read data from OLTP databases. In our case, it has been Aurora MySQL, and load data to OLAP data warehousing system. Again, in our case, it was AWS Redshift after the transformations that we choose to perform in between. So this is a pure play ETL use case that you executed in AWS Glue.